Hall of Fame, pride in the achievements of the country's space industry. On display here are spacecraft for the exploration of other planets, including our nearest celestial neighbor, the Moon. Today, there is special interest in it. Russia has resumed its lunar program. A rocket launch is one of the most impressive sights in the world. Of all the inventions with which science has enriched our civilization, the ability to go beyond Earth, to explore space and other planets, is an amazing gift. Even during the early days of Soviet cosmonautics, energy sources based on the principles of fissile materials powered our spacecraft and our lunar rovers, which operated back in the 70s. Speaking about the future, this involves, first, a lunar power station with a capacity of up to 10 kilowatts, designed to operate for at least 10 years without recharging, and, crucially, with a very low total weight. This also implies creating an engine for a heavy rocket, a space tug or a megawatt-class deep space propulsion system, as well as a range of other proven technologies, specifically the aforementioned RTGs for powering instruments and lunar equipment, which are also part of our project portfolio. Among other celestial bodies, the Moon is relatively accessible. 57 years ago, humans first stepped onto its surface.
It's one small step for man, one.
Repeating the mission proved difficult, but more than half a century later, humanity is again striving toward its seventh continent. The Americans launched the Artemis II manned mission. NASA astronauts set off on a flight around the Moon. Russia has its own ambitious goals. We are currently developing the Luna 26 and Luna 27 spacecraft. They will study the lunar polar regions, search for water and resources, and refine soft landing technologies. This data is essential for a future lunar base. With China and 13 other countries, we are building the International Lunar Research Station. Russia's contribution to this project is unique. We are creating a lunar nuclear power plant that will provide clean energy to the future base. In September, a memorandum was signed regarding the installation of our lunar dust monitoring instrument on the Chinese Chang'e 7 station, the launch of which is expected this year, and on Chang'e 8, which will be launched in 2028. Cosmonautics has become a showcase of technological achievements. The lunar race now includes not just states, Russia, the US, China, India, but even private companies. Missions are no longer planned just to bring back a few grams of regolith. This time, the Moon awaits full-scale expansion. In recent decades, science and technology have made significant advances, and lunar exploration is more possible than ever. A key requirement for this is nuclear power. Here at the Russian Nuclear Center in Sarov, scientists are already working on an ambitious space project. It is called the International Lunar Research Station. It is being created jointly by Russia and China. The base will become an inhabited research facility. In the coming years, the countries will determine a site, and then, through several missions, deliver research probes, rovers and telescopes to the lunar surface. The station will receive a command center, a descent and landing module, and a biolaboratory with greenhouses, and in the future, a residential module. Electricity will be provided by its own nuclear power plant. As of today, we have put forward an initiative to the Lavochkin Association for the creation of a low-power nuclear station based on RTGs, radioisotope thermoelectric generators.
Радиоизотопных термоэлектрических генераторов, которые преобразуют энергию распада радиоактивных изотопов в электричество.
Our estimates show that the creation of such a station will enable its autonomous operation for at least 10 years in lunar conditions.
В течение не менее 10 лет в условиях Луны.
Consequently, it will be used for preparing the infrastructure for the placement of a lunar station there, one that will eventually house a full-scale nuclear reactor. The project is so technologically complex, not just for one country, but on a universal scale, that it requires a joining of forces. The nuclear plant is planned for delivery to the Moon by the mid-2030s. Rosatom, the Kurchatov Institute, and Roscosmos are jointly working on the NPP concept.
И научные достижения еще советских инженеров и ученых.
In essence, we must take the systems that proved effective and transform them into ultra-modern systems using new materials. All the principles are known, tested and guaranteed for decades. At this stage, we have a certain linear task, so I have no doubt that we will be the first to build this nuclear station within a foreseeable time frame. No question. The famous Kurchatov Institute has long been developing nuclear space technologies. They work on rocket engines, new materials for flights to other planets, and small NPPs to power future lunar bases. This project is called Selena. They are also designing life support systems for cosmonauts and future colonizers, for example, using photobioreactors and speed breeding technologies for accelerated plant development. If we look at the life support system as a whole, we don't just need oxygen. We also need to provide water, food, and so on. It's a whole chain. And in fact, what this means is that we must create a closed system that can support all human vital functions. Such attention to all details is quite understandable. The distance from Earth to the Moon is almost 400,000 kilometers. The base must be reliable and completely autonomous. At night, which lasts 2 weeks, the temperature drops to minus 170 degrees Celsius. To literally breathe life into all objects and equipment, robots will deliver and connect the nuclear power station. The first launch, using an Angara A5M rocket and a DM booster, will deliver a service rover and specialized equipment. The second launch will deliver the standard service rover, which will operate there, and a charging and distribution station. And the third launch is the delivery of the nuclear power unit itself, after which the rover will connect the nuclear unit via cable to this charging and distribution station, and after that, the station will begin to function. The rover will also connect consumers that will be landing in the station's vicinity. Among those who worked on key projects of the Soviet lunar program were the designers of the Lavochkin Association. For example, it was also thanks to them that the first lunar soil samples were delivered. The arm descends to the surface of the Moon. It moves out like this and descends to the surface. Inside, there is a drill. Luna 16 was the first autonomous interplanetary station in human history. It contained 105 grams of lunar rocks and dust from the Sea of Abundance. This is not just a wheel, but a motorized wheel. Each wheel has its own motor. In fact, it's 8 wheels, an 8-rate drive system. So, is each one autonomous? Yes, each one is autonomous. Many planetary rovers have adopted this system. This shows how experience is utilized. The Lunokhod 3 project was incidentally classified. It was supposed to fly in '77, but the expedition never took place. But its older brother, Lunokhod 1, was the first in the history of space exploration to make a long journey across the Moon, conquering both dusty plains and rocky craters. We are now working on projects for new rovers, new mobile stations, and all the nuances gained from the operation of Lunokhod 1 and Lunokhod 2 are now applied to chassis development. Of course, with a better understanding of the lunar surface and the obstacles found there.
Да, они сейчас применяются при разработке шасси. Конечно, там немножко уже понимая, что такое поверхность Луны, что такое препятствие на Луне.
To leave any obstacles in the past, this year the National Cosmos project was launched. The tasks of exploring the planets will now be solved comprehensively. From training personnel to designing space stations and developing manned flights, the program is mapped out up to 2060. We have the Lunar 30 mission planned, which is a mission for in-situ research of lunar soil on the surface and the cryogenic return of these lunar soil samples directly to Earth. After that, we plan to deliver one of the first consumers of the lunar power station. This includes the multi-beam observatories Lunar 31 and Lunar 32. They will carry out research in different parts of the electromagnetic spectrum. We also plan to install a wireless local network on them, similar to 5G, for distributed scientific instruments. So the Moon could eventually become not only a center for deep space research, a source of minerals, but also a spaceport. In the distant future, a launch pad for spacecraft to conquer other planets. One of its directions may be the manned exploration of the Moon. And here, in addition to creating automatic probes and selecting sites and creating a guaranteed power supply base for the lunar base, there are also questions of medical and biological support for deep space flights. That is, somehow compensating for the negative impact factors of outer space, of deep space, and creating life support systems with a high degree of closure, meaning less cargo would need to be transported to the lunar surface.
Замкнутости, то есть чтобы меньше грузов было необходимо возить на поверхность Луны.
Space is both a new living environment and an infinite source of resources. If the first space race was about reaching Earth's orbit, the Moon or Mars, the current one is about staying, establishing a foothold, and moving further forward.
Закрепиться и двигаться вперед.
The prospects of the conquest of the Moon sound like science fiction, but even Soviet projects were once hard to believe. What today are called ambitious goals will one day become a chronicle of achievements and victories.
Совершение подвигов и побед.